Hello and welcome to lesson 1 of week 8. In this lesson, we are going to look at hashing and look at the hash table in Python. My name is Mildred. A hash is a data structure, and hashing is like a technique that we use to map data of arbitrary size to fixed values. And the fixed size values are called hash values or hash codes. We use this to perform fast lookup of large data, so no matter the size of the data, lookup is very fast. We have the formula for the hash to have like the hash value. You can get the hash value by using the hash inbuilt function in Python, and you pass the key to be hashed like this. And you can get the index by saying the hash value modulo the size of the array like this. Index will be equal to the hash value that you get modulo the array size. So we're going to look at how we implement the hash table in Python. But first of all, this hash function in Python is an inbuilt function and returns a unique integer, and that unique integer is the hash of any immutable object. So it only works on immutable objects, and so you can use it to test for mutability of an object in Python. So it takes a key of an element, right, and then it generates a hash code. So we'll see how we use that. Let's say, for instance, I want to print out, let's say print the hash of, let's use a string apple. It will give me a unique integer for this, and when I run this, we'll see the hash of apple printed here. So you can do the hash of a number, let's say number 42, and we run this and you see the hash is 42. Then we can also have the hash of, let's say, tuple 1, 2, 3, and when I run this, you see that it can't give you the hash of this because we need to put this in double quote. It's a tuple like this, and then we'll see the hash to give us a number. So the actual hash value may differ between runs in Python because Python randomizes it for security purpose. So when we hash an object using this hash function, they are irreversible, and this can also lead to loss of information. Alright, so remember that it only works on immutable objects only. Now, why do we use a hash? Every time you use a hash for access of maybe lookup, insertion, deletion, it's always big of 1, the average case. The memory is efficient because we store just the keys and the values, and it prevents duplicates, especially like in sets, and is helpful in indexing large data. So we have the hashing already used by default in Python in sets and dictionaries, but we're going to see how we create a hash table. Now, a hash table is a data structure that implements these associative arrays like key value pairs like you have in dictionary, and you access them in constant time using a hash function. So what we mean by this is that a hash function will map the key of an element to an index, and so the elements are stored in storage container. We call these containers buckets. Now, these elements in this bucket, they have unique keys, and the hash code will indicate the bucket to which an element belongs, and so we can easily locate it directly without having to go through. So when we look at search and sort algorithms in the earlier lessons, we see that in some of these algorithms we have to loop through the entire array or compare and find what we are looking for, and then when we do delete and insert, we have to shift. But in the case of hash, that is not it. You always go directly to the item you are looking for, and so your average case will always be big O of 1. Now, when we do this, something we call collision happens, and collision happens when we try to insert an element that has the same hash code as an existing element in one bucket. Now, there are two ways that we can solve the problem of collision, and we are going to look at them now in our code when we try to implement a hash table while handling collision in our implementation. So I'm going to clear here, and we'll start creating a class to hash table. The first method of handling what we call collision is a method we call chaining. Now, in chaining, we use arrays or linked lists to allow more than one element in the same bucket. Now, each bucket will hold a list, and it's going to be a linked list of key value pairs. Now, we're going to create a class called hash table, and we're going to use this to implement a hash table, and we'll handle the chaining method. And we're going to see a method where we add, where we search in this. So I'll create a class, and I'll call this class hash table like this. Now, the init method is going to have one parameter, which is going to be the size of the table. So we'll always have self, and then let's put size. Let me put a default size of 10. We can change this size whenever we instantiate or create an object of this class. Now, let's say self.size is equal to the size. Now, we want to initialize the hash table with empty buckets, and each bucket is going to be a list, and we want to handle this collision via chaining when we create this list. So when we have more than one element with the same hash code, we want it to make space in that same bucket to insert the new element, making it like matrix array or something like that, or it's not just like a 1D array anymore. So we are going to use a throwaway variable to loop through. We can use list comprehension to achieve this. Let's say for the table, we'll say self.table. Now we're creating a table, and this table we're going to append data pointer to it when we start creating the different methods, the add method, or we want to search the method, or we want to see if a particular element is in the table. Okay, so we'll say self.table. We want it to be a list, right? And we want it to be a list of a certain size, and the size is going to be supplied when we instantiate this or use the default size of 10. So we want to use the list comprehension, which is we'll use our pair of square brackets, and so we want to say the square bracket, which is the list. So we'll put an empty list. So we are initializing a list of empty buckets. So we want to say empty list for, I'll use a throwaway variable, which is an underscore, and this just means that you want to have an iterator that you don't really need, but just temporarily use it to loop through in the range size. So when we say we want a size of 10, so we're going to have 10 buckets, so we'll put in range size. So this is how we create a table with empty buckets of the size. So the hash key that we want to create now is going to return an integer hash value for a key. So let's create a method, possibly a private method, that we will use to get the hash key itself. So, or we will use it to hash a key. So let's say def. Now in Python, when you see an underscore before the name of a variable, it just indicates that this is intended to be a private method. Alright, so we'll just use the private method that we use within the class. So we'll say self and key. We want to hash the key, so here we'll just use the Python inbuilt hash function. So we return the hash of the key, and the formula I showed you earlier, we want to hash this. We want to use modulo the size of the bucket. Now we are using the modulo operation to ensure that the index is within the table size. Alright, because what we are storing is within indexes, and so we want this index to be within the table size. So I'll return the key modulo the table size, so that we will fit within the size of the table. Now we can create a method that we can use to add elements to buckets. So let's create an add method, or let's call it add element, like this. And this add element will take the name of the element we want to add, and then we want to get the index, which is the formula I showed you earlier. Will be self call the method that we use to hash the key. So we have the private method hash and name. Okay, so we hash the name, and now we want to append it to the table. So we'll say self.table. So we want to put the index. So the index now. So you see what we did here? We got the index, which is this name. We want to do a hash, and the hash we use here is the key that we have, which is the name modulo the size, to keep it within. So now we use that to get the index. The index is now that hash code that we have as the index, and so we'll say self.table index. Why we use this is that bucket, the index of that bucket, now we want to insert the element. So we'll say dot append the name, which is the element. So you can put this as name or element. I just use name here, whatever name you want to name your variables. So this should add an element to a bucket if all goes well. Now we want to see if it contains something. Let's say we're doing a lookup now. Let's say def contains, and we want to use a name. It's almost the same as search, but this wants to make it a boolean that returns true or false. So we'll say index is equal to self dot underscore hash name. Now we want to return the name in self dot the index, the table. So we'll pass the index here, so table index. So this will search, return true or false. Alright, we will check if the name is in the bucket that we have supplied here, because we hash it. Now we want to create maybe a search function. So let's say def search, and we'll search for an element which I'll call name. We always get the index, which is going to be self dot, we use the hash function that we created, name, and to search now, let's loop through all of the indexes and then check the items in those indexes and see if that name or that element exists. So let's use the for loop. We'll say for item in self dot, so it's the index of we'll check the index to get the value. So we'll say for item in self dot table index, we want to say if the item is equal to the name, we'll return the item. So we'll say if item is equal to name. Let's say when we search, we'll return the item. So we'll say return item. Alright, you can return item, you can return the index, and if it is not, you just return none, like this. So let's stop here and let's see how this hash table works. So we have an init method that stores the properties of this, which is the size and the table. The size can be supplied by the user. We have a default size of 10, and for the table we create a list of empty buckets that is going to be of the size that is supplied. If a size is not supplied, when we instantiate or create an object of this class, it's going to use 10 for the default. And so then we now have a private method called the hash, where we use this to hash the key, and we do this and we use modulo the size just so that we can make sure that we want to have the index within the table size. And then we now add elements method to be able to add to this, and while we do this we have an index which is going to be the hash of the name, and then we now have the name appended. So the key will be the hash code of that element. Alright, and then we have methods to search and return a boolean true or false if it contains a particular element we want to search for, and we have a search that will return the element itself when it is found. And so let us test this and say h is equal to, let's say, hash table. So we'll create an instance of this. Let's say we want to make this 5, so we'll supply a size of 5. You can do it without supplying and it uses 10 by default if I don't supply. So I say I want to have 5, and the next thing I want to do is to add. So I'll use the add element method here. So I'll say h.add. So let me add my name, Mildred. I want to let's say I want to add another one. So I'll say h.add. Let's say h.add. Let's add another. I'll put Horizon. Now I want to use the contain method. So this is add element, and here is add element. Now let's see if it contains something. So let's print h.contains. We want to see if it contains Mildred. We expect it to return true, and let's see if it contains John. It doesn't contain, we expect it to return false. Know this. Let's now see how we can search. So let's say let's print out because this returns. Let's print h.search. We want to search for Horizon and to return Horizon if Horizon exists there. Alright, so let's print out also the table. Let's see how many buckets we have. Print h.table. Now there is a likely possibility that Mildred and Horizon have the same 1, 2, 3, 4, 5, 6, 7 have 7 characters. There's a likely possibility that the hash code will be the same for these two, which will cause collision, and because of the collision it's going to change and put both in one bucket, so you have a list in a bucket. So let's run this, and then we have this. So now it did not have the same hash code, and so we have the bucket 1, 2, 3, 4, 5, and we can see that table has 5 buckets, and in this bucket we have each element inside each of the buckets. And when we want to search, the first one says if h.contains Mildred, true, h.contains John, false, h.search Horizon, it returns Horizon because it's found it. So you can actually use this to return that item, or you want to return the index position, or you want to return whatever you want to return, but I just decided to return the item if found. If I leave this like this and I leave it at the default and run, and then we have this next to themselves like this, we have 10 buckets and stored like this. Anytime you run, the hash code is randomized, and so you can see that in the table we're having them stored in different places when you repeat the same run. And in this one now the hash code became the same, and you can see how we handled collision here by putting them in the same bucket next to each other, and this is what we call chaining. So when you handle chaining in your code, it automatically adds that item into the same bucket, makes space in the same bucket for those that have the same key. Alright, so you can see what happened here. You can see that this can make search and lookup, addition and deletion very fast when we have large data, and so that's why a hash table or hash map and hash set are very important to learn. There is another method that we can use to address collision, which is called open addressing. So in open addressing, right, when we store all elements directly within a hash table array, if 2 keys hash to the same slot, that algorithm looks for the next available slot using something we call probe sequence. Now there are different probe sequence. We have linear probing, quadratic probing, and double hashing, and we're going to look at how to address collision using open addressing variants in Python in the next lesson.